Hello everybody, this is Teacher Jeff, and for today's video, I will be teaching you on how to evaluate infinite limit and limit at infinity. So without further ado, let's have our first example in infinite limit. So we will be applying first the theorem number 1 on infinite limit. So for example, the limit of 1 over x to the power of 4 as x approaches 0 through positive values or from the right. So by applying the theorem 1, since our values or zeros approaching to positive values or from the right, so our answer is always be positive infinity. Okay? So let's have another example. So the limit of 1 over x to the power of 13 as x approaches to negative values. So since our values are approaching to negative values, so we have two conditions. So our answers will be negative infinity if our n is odd and positive infinity if our n is even. So for our example, our n is odd. So our answer is negative infinity. So how about this one? So the limit of 1 over x to the power of 6 as x approaches 0 from the left or through negative values. So by applying the infinite limit theorem 1b, so we have two conditions. So since our value is approaching negative value, so our n is even, so our answer is positive infinity. Now let's move on to our second example. So for this example, we will be applying the infinite limit theorem number 2. So this one, we will just substitute the value of our x. So our x here is 3. So I will be substituting the 3 to the x. So 2 times 3 plus 1 over 3 minus 3. So remember that we need to analyze or evaluate first if our denominator will become 0. So here, our denominator is 0. So we will be applying the theorem number 2. So 2 times 3 is equal to 6 plus 1. So 6 plus 1 is equal to 7 over 0. Since our value is approaching to positive values or from the right, so our answer is positive infinity. So how about this one? So the limit of 4 minus 3x over x minus 7 as x approaches 7 from the left or through negative values. So same process. So we will be substituting the value of our x. So our value of our x here is 7. So 4 minus 3 times 7 over 7 minus 7. So since our denominator is equal to 0, so we can apply the theorem number 2. So 4 minus 3 times 7 is equal to 21. Then 7 minus 7 is equal to 0. So 4 minus 21 is equal to 17. Right? Okay, over 0 from the left, so negative 17. Since our values are negative and it approaches from the left, so our answer is yes, positive infinity. Now let's move on to our second topic, limit at infinity. So let's have our example. So A, so the limit of 1 over x to the power of 2 as x approaches to positive infinity. So we will be applying the limit at infinity theorem number 1. So whether your x approaches negative or positive infinity, our answer is always 0. So by applying the theorem, so for our first example, so the limit of 1 over x to the power of 2 as x approaches positive infinity is equal to 0. So how about the second one? So the limit of 1 over x to the power of 5 as x approaches negative infinity. So by using the theorem, so our answer is always 0. Okay, very easy, right? Now let's move on to our second example. So for this example, we will be applying the limit at infinity theorem number 2. So for our first example, the limit of 3 over x to the power of 4 as x approaches positive infinity. So same concept for our first theorem. So whether your x approaches negative or positive infinity, our answer is always 0. So for our first example, our answer is 0. So how about the second one for our B? So the limit of negative 12 over x to the power of 3 as x approaches negative infinity. So by using the limit at infinity theorem number 2, B, so the answer is also 0. So how about the letter C? So we will be applying the limit at infinity theorem number 2C. So here we have two conditions. So our answer is positive infinity if our k is greater than 0. Negative infinity if our k is less than 0. So for example, limit of 5x to the power of 4 as x approaches positive infinity. So our k is greater than 0. So our answer is yes, positive infinity. How about letter D? So here our x approaches negative infinity. So by using the limit at infinity theorem 2D, so we have also two conditions. So positive infinity if k is greater than 0 and n is even, or if k is great or less than 0 and n is even. So also negative infinity if our k is greater than 0 and n is odd, and if k is less than 0 and n is even. So now let's apply the theorem. So the limit of 11x to the power of 5 as x approaches negative infinity. So our k is greater than 0 but our n is odd. So our answer is yes, negative infinity. Now let's have another example. So for this example, we will be applying the limit at infinity theorem number 3. So here for our A, so we will be applying the theorem number 3. So for A, if the degree of f of x is less than the degree of our g of x, so our answer is always 0. So for example, the limit of 2x squared minus 3 over 3x to the power of 5 minus 7x plus 12. So here, the degree of f of x is less than to the degree of our g of x. So our answer is yes, 0. So how about this one? So the limit of 9x cubed plus 3x minus 5 over 5x cubed plus 13 as x approaches positive infinity. So here, so we have another condition. So if the degree of f of x is equal to the degree of g of x, then we need to write our leading coefficients of f of x and the leading coefficient of our g of x. So here the leading coefficient is 9 and our denominator is the leading coefficient is 5. So our answer is 9 over 5. So we forgot to put here limit of as x approaches positive infinity. So our answer here is 9/5. Now, let's have the last example for our C. So here, if the degree of f of x is greater than the degree of our g of x, so our answer is whether positive or negative infinity, or if our x approaches to positive infinity, so our answer is positive infinity. So if our x approaches negative infinity, so our answer is negative infinity. So here, so our x, so the limit of 4x cubed plus x plus 1 over 2x squared plus 5. So as x approaches positive infinity. So by using by applying the theorem 3c, so our f of x is greater than the degree of our g of x. So our answer is yes, positive infinity, since our x approaches positive infinity. And that's all, and see you next video.